Today we're going to be doing our first warm-up. You're going to see that throughout this 9 weeks, you're going to get more and more things that are for the EOC review. One of these is the EOC review. One is going to be the review of the 30, 60, 90 rules, which will apply to the EOC also, but it's also going to apply to today's worksheet. The first one starts off saying that Elliot planned his sales route by looking at a map. He left Augusta, which is at 0, 0. Guys, 0, 0 is going to be this point down here. You're going to go through and mark this. If you cannot see it, mark it clearly. This is where he's starting at. That's his starting point at 0, 0. He's then going to go to Brookline, that's not Brooklyn. Brookline, and he is going to go to the point 8, 2. The point 8, 2 would be over here at 8 and then up 2. So he's going from this point to this point. Draw that line, connect where he goes to on his path. The next place he goes is to Charleston. At Charleston, he's going to the point 4, 5. The point 4, 5 is this point right here, so he's going from here to the point 4, 5. Connect those. The last thing he does is return home, so he returns to where he began from. Connect those. He is making a triangular path. They are going to ask you to use your ability to find the distance of those to find out how far this path was. It says his total miles he drove on this route is what they want you to get. They want you to get this route going through. Now, guys, look at the question though. It doesn't ask you for the route for one day. It asks for the question for the route for, how many routes is that? 5 days worth. So most people are going to get the answer wrong on this because they're going to get the answer for one day, and it's one of the choices. It's 5 days worth of routes you got to do, so be careful. Here we go. To do this problem, we're going to use Pythagorean theorem. We've been using this all year. We have this on the next test that we're going to take. It's going to be on the worksheet we're doing today, and we've done it earlier in this year. Here we go. First one I'll do it with red just so you can see it really clearly. I'm going to use this side, and I'm going to make a right triangle using that side, and I'm going to do Pythagorean theorem. Draw that in. Okay. So I'm not even going to make you count because the lines are kind of blurry, but here we go. This is 8 along this side. This is 2 along this side. If you could see the grid lines, you could just count blocks, but they're kind of hard to see. So putting that out there. We're going to call this x or whatever variable you would like to call it. And we're going to do Pythagorean theorem. When you do Pythagorean theorem, the hypotenuse has to come last. So when you do this, it's got to be 2 squared plus 8 squared equals x squared. Guys, it doesn't matter whether the hypotenuse is a number or variable. It has to come last. Okay? In this case, x is your hypotenuse, so it has to come last. Here we go. Do the math. What's 2 squared? 4 plus 8 squared is 64 equals x squared. 64 plus 4 would be 68 equals x squared. Now look at your answers. When you take the square root of this, these are going to be rounded because these have decimals in them. We're going to go out 2 places. Why are we going out 2 places? Because the answers go out 2 places. So round to the nearest hundredth, guys. Round to the nearest hundredth. What's that give you? 8.25. Thank you. Equals x. Wonderful. So this side right here is going to be 8.25. The next one I'm going to do in blue. This one right here is going to make our triangle with our right triangle. Take a minute and draw that. Take a minute and draw that. So from there, we're going to put the measurements on here. So this, again, I'm not going to make you count blocks because it's a little bit faded. So this is going to be 3 blocks. This is going to be 4 blocks. We're going to do Pythagorean theorem to find this unknown. I'm going to call it y. You can call it any variable you want to. You can call it x again. I like to call it different variables just because it's in the same picture. That's going to be 3 squared plus 4 squared equals y squared. Pythagorean theorem does not always have the variable last. But we're looking for the hypotenuse in each one of these. That's why it's last. Okay, what's 3 squared? Come on, guys. 3 squared is 9. 4 squared is 16. What is 9 plus 16? 25. Oh, that's a perfect square. That's easy. square root, and what is it? 5. 5. It's a 3, 4, 5 Pythagorean triple. It's one of those special triangles that we talked about. Is very common and shows up all the time. Okay, last one I'll do it black because the other colors are so light when you trace them. I'll do this one right here. Draw this last triangle in. Okay, this one is going to be 4, this one's going to be 5. Again, normally you would count blocks, but it's kind of faded, so I'm not even going to make you do that. We'll call this one W. You can call it whatever variable you want to. I did W because my Z's look like 2's. Okay, so it would be 4 squared plus 5 squared equals W squared. 4 squared is 16 plus 5 squared is 25 equals W squared. 16 plus 25 is 41. And then take square root. Now you got to go out 2 decimal places when you round it. 6.40. Okay. That's going to be 6.40. So guys, so far you have worked on a coordinate plane. You've connected points on the coordinate plane, so you know where those are. You've identified points, ordered pairs on the coordinate plane. You have found distances now using Pythagorean theorem on the coordinate plane. We've done 3 different things just so far. And the last thing is to find the perimeter. And, well, actually, no, there's 2 more things. Then once you find the perimeter, you got to remember it's for a week. It's for a week. Okay, watch. Here we go. What do we do with these amounts? Add them all up. We got to add them all up to get the perimeter of that. See how long that trip is. 6.40 plus 8.25 plus 5, and you're going to see why people miss this problem. What's that give you? Okay. Do y'all see? Most people, when they see that, they're going to be like, oh, that's one of the answers, and they're going to circle it. But what do you have to do to the 19.65? Times it by 5, because it's Monday through Friday. It's not just on Monday. It's not just on Friday. It's not any specific day. It's all week. How long would that be? So from there, multiply that. It's either 95 or the 98.25. Which one is it? The 98.25. So that's going to be A. All right. Questions, concerns, anything about that problem? If I'm looking for, guys, just so you know, warm-ups are going to be a bigger part of your folder check because we're going to be doing more warm-ups this 9 weeks and next 9 weeks. So in that section, please make sure if I do the work, you do the work and put it on there. Okay. So the last part of this is just reviewing the concepts for 30, 60, 90 triangles. Okay. If you're going to go on, this is not yesterday's. Remember, radical 2 for yesterday's. That's on 45. It's the only magic number. Today we're dealing with the 30, 60, 90. If we had a 30, 60, 90, and you do not have to draw this, I'm just sketching it real quick so we can see this. If you had a 30, 60, 90, if I am going to move from the short leg to the long leg, would I be multiplying or dividing? Multiplying. By what? I'm going over the right angle symbol, so I'm going to multiply by radical 3. How do I know? Because I'm going over that right angle symbol, so I know I got to use the radical. So it's radical 3. For the next one, if you go from the short leg to the hypotenuse on the other side, are you multiplying or dividing? Multiplying, because you're getting bigger. And what are you multiplying by? 2. Multiplying by 2. If you're going from the hypotenuse backwards to the short leg, are you multiplying or dividing? Dividing by what? 2. Dividing by 2. Good. Right? And then last one last one of these type. To go from the long leg to the short leg, multiplying or dividing? Now guys, long to short, it tells you. Long to short, you're making it shorter. So you're dividing. And what are you dividing by? Radical 3 is correct. Now, what are the 2 parts you cannot move between? One class got this, one class didn't. What can't you do, John? Long leg and hypotenuse and long leg. Doesn't matter which order you put them in, just those 2 things. So the hypotenuse hypotenuse, and the long leg. There is no number that goes between those until you get into fancy trig. You can do cosecants and some other things and get there eventually, but we're not into that. Ooh, guys, tomorrow, just so you know, we get to start playing with those buttons on your calculator, the sine, cosine, and tangent. We start trig tomorrow. I love trig. Okay, guys, here we go. From here, we're going to